very good. All right, our next update will be the National Coatings Group. Jeff from Florida is going to update us on the...
This is the update presentation of what the National Bridge Preservation Coatings Group has been doing over the last year. The presentation is divided into two parts. The first part is the NCHRP Domestic Scan 1503, which is really, quite frankly, the majority of the presentation, and also other interests and pursuits of the group. So I'm going to start with the domestic scan over here. I want you to notice something over here. The bottom over there that says the National Cooperative, on the bottom footer, which says National Cooperative Highway Research Program. This was all prepared by Justin O'Sell, who tried to make sense and make this presentation for the domestic scan. The domestic scan was called the Successful Preservation Practices for Steel Bridge Coatings, and it's the desk scan summary report. The main report is still coming. It should be out very soon. So they did a little research, and they wanted to determine what corrosion actually costs. And so what they found over here was the direct cost was $276 billion between 1998 and 2001, pardon me, 1998 and 2001. $8.3 billion just for bridges. The Highway Transportation Fund income for 2001 was $29.1 billion, which kind of shows that bridges were a big part of that, and that basically is that's the Highway Transportation Fund as a whole. So the scope of the domestic scan, what was the scan trying to look into? They were investigating funding levels, evaluation of in-situ coatings, surface preparation, coating system decisions, warranties, coating inspection requirements, inspector qualifications, and contractor qualifications. Now, there's a note down here that says shop coating specifically excluded, but there is one reference in there, and I'll point that out as we go through it. So who are the panel members? The panel members, the ones that really ran the scan, was Paul Vinnick of Florida DOT, Charlie Brown of Maryland, Ray Bottenberg of Oregon, Justin O'Sell from FHWA, Tom Schwert from Texas. Hey, who's here from Texas? Tom's a real pistol, isn't he? Do you know him?
Yes, I do. I can't imagine you two together.
Neither can I, and I lived through it. Mike Todson of Iowa. The participant states were Florida, Maryland, Oregon, Texas, Washington, Virginia, New York. Golden Gate Bridge District also participated. Michigan, Ohio, California, Pennsylvania, and the NASA Kennedy Space Center, who has done a lot of research over the years, and they were a big part of this whole effort. Agency funding levels. All 13 agencies that participated have preventative maintenance programs. 6 agencies have dedicated steel bridge preservation programs. Most, and I believe this is what Justin is saying, the more organized you are, the more effective you are as an implementer. And again, he has a little note down here that Maryland is seeking to do no more repairs to beam ends, which is a lofty decision, because that's where a lot of the problems are. A lofty pursuit, I should say. Selecting coating candidates. Well, you start with a triage of either using NBR or element level inspection data. Of course, now with the new BRM, everybody is going to have inspection element level data, but in the past, that hasn't been the case. Bottom line is, if you had the NBI data, you'd have to look to see what condition your superstructure is, and then the same way with the element level inspection data, you conduct a special coatings inspection. That's an engineering evaluation to determine whether or not you have to remove the coating system in its entirety, or you can do an overcoat or entertain spot painting, depending on your funding levels, et cetera. And you got to prioritize your work and go about doing it, depending upon available funding. Same slide over here, but Justin is telling us leverage agency-defined elements, and then he says over here, he says element 515 isn't a panacea. We all, in Florida, we have agency-defined elements, and I think a lot of you out there do too, and that may be just a little quicker way to get to what you need to know. As another note, Oregon, they look at the entire condition of the superstructure coating system. And I'm sitting here looking for Jeff Milton. I guess he left the room over here, but Virginia apparently looks at coating condition of beam ends, and, but they do look at the whole superstructure system, but that's where they're concentrating. So they got the same issue that Maryland does. They're trying to deal with that issue. And of course, that has to do with deck leakage and deterioration that can occur on the beam ends. So we have overcoating over here, and you're comparing overcoating to blast and recoat. You obviously have safety regulations and environmental regulations for both. However, you have more risk with overcoating because there's a lot more that's involved, and if you don't do it right, it doesn't last as long. And it generally doesn't last as long anyway, but you won't get good results unless you really do your engineering up front and take due diligence. And Justin indicates over here, Caltrans is an exception. And I talked to them at the scan tour, and they purposely extend service life of lead-based coatings, and they use in-house paint crews to perform the overcoating. This is very interesting, because what they've determined is that it was cheaper to just try to extend them. Of course, at some point, you have so many coatings on it that you can't keep it, but you know, it's hard to argue with this concept, because they went out and you have to do the containment, and you have to do the disposal and everything else, so they felt as though they get a better product and it lasts longer. Eventually, though, they'll all have to come off if the bridges last long enough. Surface preparation, for anybody that's been going to and listening to me over the last couple of years, is the big issue. All agencies specified SSPC, SP10 for total removal and replacement. Here's a little quiz for you. Our coatings expert, Paul Vinnick, had addressed me to this slide, and he asked me about these rivets. And I took a close look at them, and I said, they're not rivets. Anybody knows what they're looking at over here? You ever heard of tension control bolts? This is kind of like deviating of the structures over there. Those are the bolts that come out. They got a rivet head on one end, and when you tighten them, they twist off. They twist off bolts, and you get the right torque. The question is the right tension. We only used this once on a historic preservation bridge in Florida, and we used them in conjunction with DTIs, direct tension indicators, so that you could determine that you had enough tension to justify a slip critical connection. But it's just interesting, and the two clues you have over here looking at this is you can see the stiffener over there, you can see the bolts coming through, but if you look at the rivets, or the rivet-shaped bolts, and you can see this little flat surface on the end, I have one of these just like this in my office. Okay, continuing with surface preparation. Varied for spots painting and overcoating are varied. All SSPC guide utilized SSPC Guide 6 for containment. Over here on the left, you can see where they're vacuuming up the product of the cleaning, and you can see these are two Maryland pictures, and you can see the containment on a truss bridge. Okay, this is kind of interesting. Surface preparation. Oregon uses a high-pressure washing system, and they use greater than 20,000 PSI to remove pack rust. That's the first time I'd ever heard of that, by the way, and they claim it works. Texas, on the other hand, uses a water blast. They use SSPC SPWJ4 before any mechanical surface preparation, and New York does something similar, which is hot pressure wash at 180 degrees Fahrenheit at 3,000 PSI to remove surface contaminants. The bottom line is that Texas and New York were looking to remove the surface contaminants, and Oregon was actually looking to get into the pack rust. Okay, coating option decision making. The scan tour concluded that 3-coat inorganic zinc is the workhorse. Expect 15 to 30 years for total removal and replacement, general satisfaction with these systems. Florida, for one, is not generally satisfied with this system. We've had a lot of problems with it. We were having trouble because we had poor application for a while and poor surface preparation too, and we were having trouble just getting 15 years. Well, we tightened up our program, and we also went to an overcoat, and now we're getting pretty good service life on those bridges that we want to have low aesthetic coating on. Of course, that's 4-coat system. Ultra-weathable coating systems, siloxane, polyurea, fluoropolymer, lack of data to justify cost, none submitted to AASHTO, NetPep. What the issue is over there is that they have been unable to verify how long these systems last. I think everybody believes these systems last longer, and that's going to be a subject of a later presentation I have later this morning in what needs to be done to prove this. Because It's hard to make it's hard to basically go ahead and change a program and use something that's unique and more expensive if you don't have data and you don't really know what you're getting. Metallizing, New York and Ohio have multi-decade experience. No rusting, though not aesthetic. Well, they didn't use duplex coatings, but I got to hand it to these states over here. They're all over there, and they're using metallizing. It's a good system, and they're apparently very satisfied with it, and they're moving forward with it. Warranties. Maryland and Michigan have a 2-year, 25% of the total project value. Oregon uses 3 years, 90% of coating aligned items. Golden Gate is 5 years, contracted labor and materials. Presumably that's 100% of the coating line items. I don't know, Jeff, you there, is that true? Okay, I don't see him. Oh, pardon me, Virginia has 1 year, sorry. Ohio has 3 years in the past, and the reason they gave up on it was because they weren't tracking it. This time period would pass and they would find problems. Oh, we should have got back into it and done something and held the warranty up and they decided there was too much of a problem to track. So what did the scan tour conclude was a sweet spot? And they concluded that the Maryland-Michigan way of doing business was the best. And the reason for that is that within 2 years you're going to find out if the coating system is performing well, and you're going to be able to know that if it isn't. Now, the 25% total project value, that's not going to pay for the replacement. What that's going to do is hopefully give the contractor the incentive to do a good job, and it's also going to keep your bonding down. So it should result in less failures out there because the contractors are going to know we're serious about, looking at this down the road. And basically, they'll have to have a financial penalty if they do. Coating inspection requirements. One agency had in-house personal QA inspections. 5 agencies, including Florida, had consultant personnel and QA inspections, and there were 6 agencies that had a blend between in-house consultant and QA inspections. Minimum consultant certifications, at least NACE CIP level 1, or its approximate equivalent SSPC BCI level 1, and some states used NACE CIP level 3 or their approximate equivalent SSPC BC1 level 2. And I'm not saying when I say approximate equivalent, one is better than the other, but they're approximately equivalent to each other. Minimum in-house certification varied. Hold points. This is something that we've been discussing for years. If you're out there and you're doing a coating job and it's not going well, you really need to say, stop, Mr. Contractor, your QC plan isn't working well, you need to make some adjustments. Or if you don't have an inspector, you're going through a critical operation, you say, stop, Mr. Contractor, we need to get our inspector out here. And what it is 100% of QA inspection verification leads to quality. There's some contractors, they don't need to have this, they do a great job anyway. But it's hard to compete if you're a contractor and you're competing with a guy that is just doing a lousy job and getting away with it, and you're spending the time and effort to get a good job. So that's I think if everybody gets held accountable to the same thing, the good contractors are going to thrive, and the bad ones are either going to have to get better or find something else to do. And striping, the striping is where you coat the edges of girders and sharp edges so that basically you get better coating coverage. And they recommend using a tint stripe coat, and I think that's a great idea. I think that's what we do in Florida too. Inspector qualifications. All agencies require training before assigned to a bridge, primarily in on-the-job training, industry-based NACE or SSPC training, and there was some in-house inspector-led training. I'm not exactly sure how good they were. I think probably some are better than others, but in Florida we use NACE or SSPC. I don't know which one exactly, but we'd be happy with both. Contractor qualifications. 9 agencies required SSPC QP1 and QP2. What is QP1? It is prepare and apply coatings in the field. QP2 is hazardous material removal in the field. QP3 is, and then one agency did not require SSPC QP certification. Pardon me, I skipped over here. 3 agencies required SSPC QP3 for shop painting. That's the only reference we had to shop painting in here, and that is prepare and apply coatings in the shop. One agency did not require SSPC QP certification, and one agency allowed SSPC QP7 for new contractors, and that is Introductory Program for contractors with less than 6 months' experience. That's kind of on-the-job training, and if you're going to allow that, you really need to have your inspectors out there helping them out because they're just learning. Other findings. I got to hand it to Washington DOT. They're sharing their dirty laundry with us. This is a Washington bridge, and obviously this is a problem. This is basically bad detailing. They have water debris and debris trap over here. So the wet moisture soil sits right on the bottom of this, looks like a sideways wide flange or eye girder. And it just sits there and it can cause all kinds of problems. So they're talking about considered bridge washing. What do you think? You think we need to bridge wash this? I think so. So anyway, I guess they're trying to get a handle on this and they're trying to move forward. But the bottom line is this was bad detailing, and I would consider even drilling a few holes in the web to try to keep that clean. But definitely you got to keep this clean. You just can't let that moist soil sit there. When the grass grows, you can tell it's been there for a while. So other findings. The USDA bird relocation. That's something that's recommended for getting rid of birds. Or alternatively, encourage raptor nesting. And that's what Washington is doing. It's working great for them. Basically, they don't have the birds hanging out in the bridges, and the raptors are taking care of that. So that helps the natural environment. So I kind of like that solution. Other findings. Okay, eliminate deck joints. And I've heard that Virginia is in the process of trying to eliminate deck joints every year, and they're doing it on existing bridges. Now they talk about add continuity and link slabs together. We link slabs together in Florida. Presumably Virginia is linking them, together after construction, trying to eliminate them. Of course, you got to be concerned about your joint movements and everything else because you're probably going to end up with a joint at some point on a bridge that's not designed to have joints. And continuity has to be done when you originally designed the bridge. And they say move the joint behind the abutment. What they're talking about is Tennessee, I'm aware of. Is anybody from Tennessee here? I can't see over there. There you are. Those guys are the king of jointless bridges. And they do it largely because they got rock. And they can anchor their substructures into rock, particularly their abutments. In Florida, we can't do this. We're envious. But they push the technology, and I guess that's really paying off for you. This is coupon testing at NASA's facility. And what you're going to get out of this is they have all the IOZs, the inorganic zincs, look a lot better than the OZs, the organic zincs. And the thing is this, it's self-explanatory. IOZ does a better job. OZ's got, has got organics in it, and it just doesn't do as good a job. That completes this portion of the presentation, but hold on, I just want to go through the other pursuits that we've been working on. The National Bridge Preservation Partnership, over the last couple of years, has worked on submitting a duplex coating system research project. In the meantime, the NSBA metallizing guide specification, which was really kind of spearheaded by Justin Carlson of AISC, who's been participating on the group, has pretty much finished that effort, and he's working, I understand, now on the galvanizing guide. NCHRP problem 2018-D-15, effective use of duplex coating systems to improve steel bridge structure durability, was not approved by the AASHTO Subcommittee on Research on March 23rd. This is kind of devastating to us because we worked so long on it. And the interesting thing is, we came out of SCOM, the Subcommittee on Maintenance, as their #1 priority, and we came out of SCOBS, the Subcommittee on Bridges and Structures, as their #2 priority. Now, how we can get shot out is beyond me over here. I think a lot of people don't understand this. And be quite honest, coatings, unless you're into it, is not the most exciting subject. But if you think about it, it is one of the things that we spend the most amount of money on. And this system over here had the potential for lasting 100 years. Would it last 100 years? Maybe with a certain amount of refinement over time it could. but it probably 75 years might have been within reach. Because what a duplex coating system is, it's either metallized or galvanized, or a combination thereof, and has a high-performance coating system on the top. I'll just pick one, like fluoropolymer. And the theory is that fluoropolymer would have to fail before it would ever get to the metallizing or the galvanizing, and then that would have to corrode. Now, in a situation where the government has trouble funding projects, it may not look beautiful, but if you can't go out there and coat a bridge because of it, you don't have to worry about it if you end up you're down to your metallizing or galvanizing. At any rate, I'm not too happy about this. It was a bad day when I found out. The Bridge Preservation Expert Task Group, BPETG, Steel Bridge Coatings Pocket Guide, was something that was initiated by Ed Welch. He basically said, Jeff, you need to work on this. So I did the high level thing, and I got people that really know what they're talking about, because I'm really a general bridge practitioner. Ted Hopwood, formerly from the Kentucky Transportation Center, who's a great researcher, and Paul Vinnick from the Florida DOT, who's our materials guy. And behind the scenes, Paul has been helping us all along. He's not a member of this group, but he's done a lot of work for us because he sees the value of this stuff. At any rate, they've just started this effort. They've got a table of contents development. They're moving forward. So what are some of the other things we want to work on over the next year, or that I would like to work on? Warranty contracts for just what you saw earlier. I think that's something that we can work on. And I want to also tell you that, that Wayne Senek of Termarust and Regis Doucette of Chlorid International, who are members of the group. Regis is our secretary, and Wayne is our vice chair. They've been attending these ARIMA meetings with this Coating Performance Solution Specification. I'm not so sure I fully understand it, but it looks like something slightly beyond warranty contracts, because they're trying to look at a result as opposed to just trying to get an extended life within a certain period of time. So we're keeping our finger on the pulse to see how that's going. And that concludes my presentation. Oh, one more thing. These are all the people that have participated on the group over the years. Some of them are not active anymore, but I figured I'd put all their names down. I'm not going to go through them all, but there's been a lot of people that have touched this group over the years. And that concludes my presentation. Any questions? Just like the response we got when we tried to push our duplex coating through, blank stare. Thank you.
Thank you, Jeff.